At our current technological pace, our ability to continue to make ever faster and smaller computer chips is slowing. Today, researchers think that the next big scientific leap could involve one of the most powerful and mysterious forces in nature, quantum physics. Now, what would take years for current computers to do, a quantum computer could achieve in just a few moments, promising profound leaps in everything from medicine, communications, and space travel to an understanding of human consciousness itself. While labs all over the world are racing to create the first commercially viable quantum computers, fundamental questions remain about how this technology could be used or misused going forward. So we sent Taylor Wilson to investigate.
One more set of gloves and your safety glasses.
Safety glasses, thank you.
So what we do here is we try to imagine what the future will look like. And our goal here is to push the envelope to get ahead of the technology curve, so to speak, so that we're ready for what the future brings.
The future will usher in the age of the quantum computer, a device using quantum physics to create a computer with the possibility of 1 million times more processing strength than all computers in the world today combined. My cell phone has a classical computer chip, and that produces a computer code that's made up of bits, so ones or zeros. How does a quantum bit or a qubit differ than that just 1 and 0?
Imagine this coin is a bit in a conventional computer. So you see this side of the coin is a 1, this side of the coin is not a 1. A conventional computer basically flips bits to do a calculation.
Yes.
The larger the calculation, the more bits you need.
That means bits are a classical computer's building blocks. Individual data units represented as a 0 or a 1 that allow computers to display numbers, texts, images, and sounds. But a quantum computer is different.
A quantum computer, a qubit, it's a combination of heads or tails.
Okay.
And you can visualize it by thinking of spinning. We call it superposition.
When you go below the atomic level and into the quantum realm, the physics are in many ways wildly different from what we perceive. One of those unique principles is superposition, and that's what computer makers are trying to harness. In a quantum computer, the quantum bit, or qubit, uses this principle of superposition to be both a 0 and a 1 at the same time, effectively multitasking. And that's part of what makes a qubit so powerful. Classical computers run one calculation at a time, but a computer that utilizes quantum effects could run through several calculations simultaneously.
At 300 qubits, you can encode more information than all of the atoms in the universe.
Wow. Wow.
If we only had to make individual qubits work, we'd basically be done.
Yeah.
The fact that we have to make them all work simultaneously, that's what makes this a really hard problem.
The engineering needed to harness that kind of power, known as quantum supremacy, has set off a race among computer giants to get the first fully functional quantum computer. And while a commercially viable quantum computer is likely still years away, the first computing device to tap into quantum principles, called the D-Wave, is now being used by the United States' biggest defense contractor, Lockheed Martin.
We are looking at the very hardest problems, the problems that are intractable, we say, for classical computers, which just means that we can't solve them with the amount of time and resources that we have.
Yeah, problems that would take on the age of the universe or something to compute.
Exactly.
Senior quantum engineer Dr. Kristen Puddens has used the D-Wave to ensure that some of Lockheed Martin's weapon systems are error-free. Advanced weapon systems are using increasingly more complex software, like the F-35, which runs on more than 8 million lines of code.
The software verification problem is something that's particularly difficult. It's something that consumes a huge amount of resources for Lockheed Martin and for really every other company that's developing systems with computers inside it.
It costs a lot of money.
Costs an incredible amount of money. If we could speed it up even a fraction of a percent, we would probably pay for the entire quantum computing program.
And so, while the race to be the first to build a commercially viable quantum computer hits a fever pitch, an entirely new computer language is being written to program these powerful machines. So once we have quantum hardware that actually works, you're working on how to code it and how to be ready for that hardware.
Yeah, exactly.
Krista Savor and her team at Microsoft are figuring out exactly how to put the power of a quantum computer to use once a breakthrough is achieved. So how many qubits can this software kind of simulate?
You can simulate roughly 30 to 32 qubits.
Okay.
But if we go larger, let's say we wanted to simulate 250 qubits on this device. It doesn't sound like a very big number, but that will take you the age of the universe to do one operation. Let's say we want to understand, how do the electrons configure in a hydrogen gas, right, in that structure. We're gonna run the chemistry solution. And there's a lot of numbers flying by.
This simulator mimics a quantum computer, only much slower. A real quantum computer will be able to solve some of the most complex science and engineering problems almost instantaneously, effectively condensing years worth of manual laboratory testing to just a few moments. And that might reshape our world to look a little bit more like the worlds of science fiction.
If we can take, knowledge like this, we can feed that in to ways to actually engineer new materials. Imagine a new paint that could make a plane disappear, from signals, right, from your visible eye. When we think about how do we transport power, right, across, say, the United States. Phoenix is really sunny a lot of the time. I live in Seattle. Not so sunny a lot of the time. Maybe we could transport solar power really efficiently from Phoenix to Seattle. You want to do drug design, you want to better produce fertilizer, you want to find a high temperature superconductor or interesting materials. It's not just a step in computing power, this is a quantum leap in terms of computing power.
Absolutely. And while this leap in computing power opens the door to amazing science, like any new technology, it also introduces problems that we have not yet imagined, or potentially intensifies dangers we already face.
Cyber chaos this morning. Chances are some of your personal or financial information was compromised.
Russia launched a sophisticated cyber attack against the Pentagon.
In the last 5 years alone, hackers breached billions of accounts and systems worldwide. These attacks were all done with the classical computers we use today. Because of a quantum computer's speed and power, there are no current security methods we employ that could fully protect our banks, identities, and even our infrastructure. The irony is that a country widely accused of hacking intellectual property is now leading the world in creating its own impenetrable quantum technology for cybersecurity.
For the first revolution for information technology, China are the follower. So the country start to think about trying something new so that maybe in the future we can be a leader. So that's the beginning of the whole story.
At the University of Science and Technology of China, Dr. Panjian Wei, known in China as the father of quantum, has created the first secure quantum communications network as a first step in countering the threat that actual quantum computers will pose.
So here is the control center for our quantum science satellite.
This is the first quantum satellite in existence?
Right. So the orbit is about 500 kilometers.
Do you want to just take us very basically through how this process works?
So it's quite simple. We send a sequence of single photon.
Yes.
Then we try to perform a measurement onto the receiver photon. Then also we need to compare a subsequence of the general key to find out whether we have some error rate. So it's quite simple.
But not really. The scientists are exploiting a principle of quantum physics called entanglement, a concept so strange that Albert Einstein even called it spooky. Entangled photons are essentially linked across time and space and can instantly teleport their quantum information with each other over incredibly large distances.
Okay, so take the phone. Hi.
Hi. So what Pan's team is doing is linking or entangling particles to create a completely safe communication channel between two locations on Earth and a satellite using a laser. Two entangled particles are used to create a key to secure a conversation. And because of how fragile keeping a quantum connection is, if a hacker listens in on that conversation, the connection between the entangled photons will fall apart and the network will close. So the information that's actually going through this teleconference is actually being encrypted through the quantum information system.
Right, exactly. If with this line someone are performing an eavesdropping, then we can go to another optical fiber. Then we can continue our secure video conference.
But encrypted communication is just one quantum application Panjianwei is pursuing. China will be spending at least $10 billion over the next 3 years on quantum technology, including computing, around 13 times more than the US government is spending on quantum research.
Although we don't know and what is the physics behind quantum entanglement, but we do know it exists. So therefore, it doesn't matter. We can still use such a phenomenon for useful application.
And unraveling the strange nature of quantum mechanics might even take us beyond inventing new incredible technologies. It might also play a key part in unlocking one of the greatest questions humanity has ever asked. What is the nature of human consciousness?
I think the ultimate goal we want to do is we want to understand our brain, right? How our brain works. Consciousness is somewhat related to quantum mechanics. Only quantum mechanics, in some sense, gives some room for uncertainty, which is somewhat could relate to free will or consciousness.
A computer like this might actually give an answer to it.
Maybe a long-term goal can give us answer where is the origin of consciousness. That's what we are looking for.